This is the third of 3 videos to help you analyze your sprint data. By now you should have the movie inserted and you should have digitized it by marking all the points on the graph. Now we can make our graph a little bit more compact and we can see that we've already got some graphs being formed. The graph shown here is a position time graph and it has 2 lines on it. One for the horizontal motion and one for the vertical motion. For this one in here, we really only looking at the horizontal motion, so we can select that. Notice that the graph goes down, negative, and you should think why that is. This graph gives us nice a smooth pattern that helps us describe it, but mostly we want one more graph, so we're going to insert an extra graph. This graph is going to be the most important one, so we're going to make this one larger. This graph currently shows us the velocity in the y direction. That's not what we want. We want to know the velocity in the x direction, so we can change that over. Now we have our graph set up, we can see some of the patterns in it. We can see here the short delay before the racer starts. We can see here the phase where the racer is speeding up. And we can see here the phase where the racer got to the top speed before slowing down again. So we're going to analyze each of those. Firstly, we're going to insert a text annotation. These are very helpful for labeling your graph. It takes a little bit of practice to be able to move them around. We can move the box and we can move the end of the arrow. This one shows the end of the reaction time. So I can label it reaction time. And if I look at the scale here, this is 1 second, so this is 0.2 seconds. So we can estimate the reaction time here to be 0.1 seconds. Move that down a little bit to give me more space. The second part of this is we want to know the initial acceleration. So we know that looks with these points here, getting faster and faster. And so there what we do is we will go and insert what the computer calls a linear fit. This gives us quite a lot of data to explain this, and you may recognize the equation for a straight line here. From this here, we can see that the initial acceleration, which is the slope of the graph, is given at 3.242 per second. It's helpful to have a text annotation to point out what's the important part of that, since there are quite a lot of numbers. So we're going to take another text annotation here and move it so that it points to the right number, the number that we're interested in, and we'll tell what that is. So that's the initial acceleration. When we write that value down, we can leave out the negative because that just tells us the direction. We can round off the figure a little bit so that it's more realistic, and we make sure that we've got our units. Lastly, we're going to identify the top speed. The very top speed would be one of these points, but it may be more sensible to take an average because all the bumps and things may well come in this video from the camera moving. So for this one, we can use the statistics button to produce some statistics for the part of the graph that we've selected. Note here that we've dragged around an area of the graph so that we're just looking at that bit. And from this one here, we get a mean value of 4.481 for the velocity. So that's probably our best estimate. So one more text annotation. Take our text annotation, move move it to a convenient space. Make sure that it points at what we're interested in, and label it maximum speed. And again, we can round this one. In this case, we can round this one up to 4.5 meters per second. I think my thing has gone off the graph a little bit. So now I have my complete analysis with my reaction time, my initial acceleration, and my maximum speed. Now is a good time to save the graph. So